Hi, there we are again. So this is the last presentation for today, and this one as well is going to be about color, but I'm going to focus on just one topic, and that is color comparison. I want to explain what the possibilities are now in pdfToolbox 12. So not comparison in general, but specifically color comparison. And then I want to show two possible applications. If you joined the previous session, then you will know. If you joined the session at 3 p.m. today, then you will have seen already one possible application, but I'll explain it in detail here. And then the other one is completely new. This is a little bit of a work in progress presentation in the sense that I don't believe we have a complete solution, especially for the second topic I'm going to be talking about. I know it's all very secretive right now, but so I don't think we have a complete solution, but I want to show what we've been working on, and then if people are interested in the topic, I would urge you to get into contact so that we can work with you and make something that actually works in your workflow. Before I start, let me remind you that there are still two sessions tomorrow. The quiz at 3 p.m. and then at 5 p.m. there is a recap session where we will have very short reviews of the most important features that we've introduced for pdfToolbox 12. And let me also remind you that you have a chat window and a frequently asked questions part in Zoom where you can ask questions. And please do that when you have them. Don't wait until the end of the session. Someone is looking at them as I give this presentation, and they will interrupt with questions. So, in many cases, it's necessary to do something to color in a PDF. And there are all kinds of reasons that this might happen. And there are a number of different, I call it engines, that pdfToolbox provides to do this. The first area is that anything with spot colors can be modified. You can modify how a spot color looks on screen. You can rename it from one name to another. You could remap all objects that use a particular spot color to something else in the file. You can remap a spot color or convert a spot color to CMYK. All of those things are possible. Second thing that you can do is ICC-based, ICC profile-based color conversions, which means that, for example, I use a convert color fix-up to go from RGB content to ISO-coated V2 content. And then the last thing that you can do is you can do transformations using device link profiles. And that typically would be done, for example, to convert from one standard to the other. It could be sRGB to CMYK, but it could also be ISO-coated V2 to PSO-coated V3, for example. Yeah? And you can also use device link profiles to do things like ink save and well, similar applications. Important to mention perhaps is that the profiles themselves can be used, but they cannot be created using pdfToolbox. Yeah? So you get a number of built-in device link profiles, and you can use any other device link profile as long as it's a standard device link profile that is unlocked. And you can use any ICC profile as well. When we go back to the topic of color conversions, the question then becomes, how can you do this in a safe way? And how can you see what the result is of such a conversion? And when I'm saying that, I'm referring both manually and automatically. What do we have? And let me explain that to a second. In pdfToolbox 11 and before, you had a a comparison technology, and it was only available in either the desktop or in the CLI, and then you could use the visualizer images in the CLI to visualize the result there as well. And it was not so good when you wanted to do color conversions and then do comparisons, because what typically happens in the compare engine is that it takes the input and the output file and it does a rendering that is in one color, so a grayscale rendering if you want, and then it does a comparison between the pixels of, so the page is converted into two images, each before and after is converted into an image, and then each pixel of those two images is now compared, and yeah, as soon as there is a difference, it is registered as a difference. And then you add some parameters to influence how quickly pdfToolbox was going to decide that the two files were different. But because of the way this was done, it was very unsuitable for image comparisons or for color-based shifts. Yeah? So if you have a file and you do something with that file that is color-based, and then you compare the before and the after, you got almost always the result that the files were different, which they are. And you couldn't really adjust the options that you had, the parameters that you had, to allow those files to pass that had small color differences and still stop the ones that had large color differences. That was a very difficult thing to do. And it's not surprising, the engine wasn't built for that. So what we introduced in pdfToolbox 12 is something that is made exactly to resolve that problem. Yeah? A new comparison mode that doesn't look anymore at well, it still does pixel comparison between before and after, but it doesn't just look at the content of the pixel, it really looks at the color difference between those two pixels. And in order to do that, it needs a measurement of what is the difference in color between those two pixels. And pdfToolbox implements 4 different algorithms that you can use. And you can see them listed there, delta C and delta E. And I will take the time to at least explain in a little bit of well, detail what those are. And let's start with the oldest one, and that's delta E 1976. And you can write it in full, or you can use the Greek letter to do it, which is normally done if you're looking at the formulas and so on as well. And you see the formula there at the bottom. Now, if you know anything about mathematics, and trust me, I will not hold it against you if you don't, but if you know anything about mathematics, that thing calculates a distance in a 3-dimensional space. Yeah, so if you just in the space where we are now, if you would have 2 points and you want to know what the distance between that is, you would use a formula that is very, very similar, except that you would use x, y, z coordinates. That is what they typically are called in our 3-dimensional space, while here what is used is L, A, and B, because it's typically done in an LAB space. Yeah? But that is exactly the algorithm. Someone said, okay, we're using LAB. LAB is an abstract color space. It is supposed to be a perfect color space. So what is the difference between two colors in that color space? Well, it is the distance between those two colors. And so the formula literally calculates the distance that you have in that 3-dimensional space. That's a great idea, except that it doesn't work, because while theoretically this is a very bright way of doing it, this is not how our eyes work. Our eyes are more sensitive in certain areas than they are in other areas. And so you might have now a good way of calculating a distance, but that doesn't mean that it corresponds to the way our eyes react on color differences. So we implement this delta E 1976 in pdfToolbox. But whether or not you want to use it depends on what exactly you're doing. I've heard arguments that this is actually a good color measurement in certain areas. Yeah, but there are more modern calculations of delta E, and there is one, for example, from 1994. Yeah? It's important to mention that this one is not implemented in pdfToolbox. And the other difference is, well, you can see that it's more or less the same approach. This looks a little bit similar to what we had before, but it looks already a little bit more complex. And in reality, it's more complex than what you see here, because there's a lot of stuff on there. This K, S, all these letters, sorry, that are used in this formula. It is not explained where that comes from. So in reality, there's a bunch of formulas behind this that let you calculate this. But the goal of this was to correct for the fact that our eyes are not uniform. Yeah? They introduced correction factors to deal with that. And when you look at the one that is implemented in pdfToolbox again, delta E 2000, that is exactly the same principle. So this looks even more complex. And the reason is that, again, it implements additional corrections. Yeah? For example, our eye sensitivity is very different when it comes to the blue regions in a spectrum. And this formula corrects for that, or at least attempts to correct for that. If you think that this doesn't look much more complex than the previous ones, this is what Wikipedia has to say about how this thing is calculated. Yeah? So these are the formulas that are behind that smaller formula, and all of a sudden it becomes a lot less interesting to try and understand what this does, right? The only thing you have to remember is it is still this distance in a three-dimensional space, LAB space, but it has been corrected with a large number of factors so that it comes closer to the sensitivity of our eyes. So that is for delta E, and we implement, as I said, the 76 and the 2000 version. When are two colors the same? Because what delta E does, it gives us a number, and this number can be 0. If it's the same color, it's going to be 0. That number is well, I shouldn't say that. That's very confusing. If it's the same point in three-dimensional space, so if instead of this I have 2 points that are identical, then it's going to be 0. Or that number can be a positive number. Yeah. So when are two colors the same? In reality, this too is a little bit subjective. No two people have the same eyes and are equally sensitive, and there are all kinds of differences. The general guideline kind of is, and I think my numbers are already a little bit different from what Dietrich at some point mentioned, which shows that this is subjective. Yeah? But a guideline you can have is that if it's smaller than 1, they are equal. If it's between 1 and 3, the definition says it is hardly noticeable, which means if you look at this, you're probably not going to see a difference. You really will have to have someone who is very sensitive to color or trained on seeing color differences, and you will have to examine this thing. Yeah? And if it's larger than 3, it becomes what is called noticeable at a glance. So even casually looking at it, you might see this color difference. So delta E and the definition of when is something the same and when is it different. The second thing that we implement in pdfToolbox 12 is delta C. And delta C is, and I'm not going to take too much time on this, it is very similar to delta E, but it doesn't take lightness of a color into account. So basically, if you're looking at a color that is the same color, but two different lightness levels, one is a little bit darker than the other, then delta C is not going to take that into account. And if you think about this in LAB space terms, it means that it doesn't take the L coordinates into account, only the color parts A and B. So what can you do in pdfToolbox 12? In the desktop version, you have an implementation of this in two different areas, principally. The out-of-gamut checking, which uses delta E values to determine whether, if you have a PDF file and you would render it using or color convert it using a different profile, that determines will it then still be in the gamut of that, and that uses color differences. And it is used, and this is what interests us here, it is used by compare PDF, where I can have a before and an after PDF and then compare those two. And this, at least I want to show briefly. And let me see which PDF files I have here. But those are the ones that I want, I think. And then we're going to go to compare documents. And now I hope that it selected the two correct ones. Yes, because I have another one open. And where, well, obviously these are not the same. Yeah? What I have here is a document, and then I also converted that document to PSO coated V3. And then I get this. And my color conversion was definitely not the best I could have done, but that's also not important here. The main thing I wanted to do is show you what the differences are and what you can do here. And now this document is almost completely red, which means it's almost completely different. Not very helpful. But of course, now I can start playing with things. So I could say, oh, I want to do this comparison, but I only want to look at the CMY channel. So I'm not interested in comparing the black content. I'm interested in everything else. So that you can do that. Yeah, but that's not why we're here for. What interests us is these things at the top. Yeah, where I can select delta E 1976 or 2000 and the same for delta C. So if I would choose delta E 1976 and then I have I put a value in there, then I would hope that it would do something. Is it actually looking at the correct files? Because that's, it would be better if I would select the correct file. Yes, there. So I've set it now to delta E 2000 and I've set it to 5. So basically, if my delta E calculated value is higher than 5, then I'm getting a little dot here. And you can see that there are just a few places where it finds that dot. If I would set it higher, then it is going to say there are no differences. Yeah. So the method that we're using is important, of course. Yeah. So it could make a difference whether we're using delta E 2000 or delta E 1976. It's a different algorithm. So that is going to be important. And then next to that, what is going to be important is the threshold that we're setting here. Now, this is in pdfToolbox desktop, so the manual comparison of documents, but of course it would also be interesting to do this automatically. And then the question becomes, what can we do on the automatic side? And I already introduced what you can use in a previous session. When you look at process plans, there is a new process plan step that is called compare PDFs. And if you look at the properties of that, it allows me to do something very similar to what we saw before in the desktop version. I can choose which file I want to compare to the file in this step. And then I can choose a method. And the method, again, includes these delta E and delta C calculations. And so I can say that if my files using delta E 2000 have a maximum color difference of 5, I'm going to call them identical. That is what these properties mean. If I get a delta E calculated between the two files that is larger than 5, then they are different. And the process plan is then going to process the results in that way. So if there are differences, it is going to send it to the red exit that says on differences. If there are no differences, it's going to the green exit. So you can do it in a process plan, but sometimes you don't need a process plan. You just know that you have two files and you want to compare them. In the CLI, you can do that, and in the SDK you can as well, by specifying in the compare mode, our action, I think it's called compare. In that compare action, where previously you only could do this pixel-based comparison on the content of the pixel that we talked about, now you have additional modes for the delta E comparisons that we talked about. Yeah? LAB corresponds to delta E 2000, LAB 76 corresponds to delta E 1976, and then the other two correspond to the delta C based comparisons because they don't take L into account. So you can also do it there. Okay, so let me see if we can make things a little bit more interesting. And I'm going to open this process plan that you saw on the slide. And let's look in a little bit more detail what happens here. Well, the first thing that happens in this process plan is that I get a color conversion going on here. So I have a conversion to PSO coated. It is done in not a very good way, I believe, because what I'm doing here is I'm using an ICC-based color conversion, which is guaranteed to give me trouble unless the files that come in are, for example, RGB, in which case it might not be too bad. But for our demo purposes, this will do just fine. And then after that, there is a compare PDF. And this compare PDF needs two PDF files to compare. And where it gets them from is the first PDF file comes in through the normal connector. And then the second PDF file comes in through this alternative connector that you have here, the one that has these dashed line, and that goes back to the color conversion. So it takes the file before the color conversion and it compares it to the file after color conversion. And that's exactly what we want to compare. And you can really draw this as a line from here. So I can draw a line from this connector to any of the other steps I have, and then I will compare to the file at the beginning of that step. Or you can use the properties area, and there you see it as well. Yeah. Here I can select the step as well. And then the next bit is that if I do the comparison and there are no differences, I have a specific exit for that. And in this case, it just goes to the end. If I do the comparison and there are differences, then I'm sending it to another outgoing connection, and then I can choose to do any kind of error handling that I want to do. And in this case, I do a file pickup step, which will pick up the before file. So what I'm basically implementing here is a process plan that says, do a color conversion. If the differences in color are too big after the conversion, then go back to the file before you converted it. Yeah? So it will only save the converted result if the files are pretty similar. And then the parameters are pretty straightforward as well. I can choose which comparison method I want to do. And if you're working with color, it should be one of the four first ones, normally delta C or delta E based. We've talked about that. And then, and I didn't want to click there. And then after that, you also have to set up the other properties, and that is, what do you want to compare? So which page box relative to which corner, which is important if the both files have a different size. And then what is the threshold? So if I do delta E, from which point on do I consider files different? And then I have a resolution for rendering as well, to decide at which level of accuracy I want to do this comparison. But obviously, the higher this is, the longer your comparison is going to take. So that's the simple and straightforward example, I would say. And then we look at something that is slightly more interesting, but a little bit more complex, as you will see.
There's a question.
Yes, let's do the question before we start to confuse everyone.
I think you would understand the question because I don't. The question is there also metadata which says conversion okay or not?
The compare PDFs, metadata not, but compare PDFs gives you a result. In the process plan, you can catch that by going to one connection or the other. You have two connections and you can label them with what you want. In a CLI action, for example, there is a different return value, exit code, whatever you want to call it, result code. There is a different code depending on whether the files are the same or not. Yeah, cool. So the next bit is something that, like I said in the beginning, it's something that we have been working on and that is definitely not ready. But we think it is something that could be interesting and that, well, has to be tested. So this is a slightly more complex process plan, only slightly, and I'm very happy to have the new process plan editor and not the old one, because that would have driven me absolutely crazy to make. Yeah. What it does is it tries to see whether a file is ready for EPM or not. And I'm using EPM because that's a known concept, but there are a few different technologies that play around the same principle. Yeah? Think about a digital workflow. And in this digital workflow, you have files coming in, hopefully. And then you need to decide, you need to print this file. And there are two considerations when you have that type of workflow. The first one is you probably want to print them as quickly as possible. And the second one is you probably want to print them as inexpensively as possible. Yeah? And both of these considerations give rise to this EPM concept. What is EPM? It stands for Enhanced Printing Mode, Enhanced Production Mode, you choose. The concept behind it is that it surely must be quicker and less expensive to print something with 3 separations than with 4. I think theoretically we can kind of all agree on that. If you only have to print 3 separations, it should be faster and it should be less expensive than if you have to print 4 separations. If you only have to print 1 separation, that effect gets even bigger. So in EPM or in similar technologies, you have 2 concepts, 2 things you can do. We could take a CMYK file and say, oh, but modern digital technology is so good that we don't really need this K separation anymore. We're going to print everything using CMY. And then you go from 4 separations to 3, exactly what we were talking about. You could take it one step further and you could say, oh, but what if I could analyze the document and I could find out which pages of the document are black only context, and then the pages that are not black only, so the ones that have color on it, I'm going to print in CMY, and the ones that have only black, I'm going to convert to something that really will be printed as only black. Okay, now we're talking about EPM. Yeah, that is exactly what this is about. I want to see if I can print my document quicker and if I can print it for less money. And surprisingly enough, I've always thought that the less money part was the most important. Surprisingly enough, when you start talking to people, for many people, the fact that you can print it quicker is at least as important and maybe even more important than the fact that you can print it for less money. So, what do you need to do if you want to see whether a file is ready for such an EPM workflow? Well, you need to check it. What do you need to check? Well, if you look at this process plan, the way it is built, and I will run it in a second as well so that you can see what actually happens, but the way this is built is that there is a variable at the beginning, and this variable will allow you to choose between EPM and EPM plus K. Yeah? Acronyms all over the place. EPM is what I said, where you take a document and you print all of it using CMY. So you drop the black channel. Well, actually, there is a conversion going on to compensate, of course, but you print only using CMY. And CMY EPM plus K is the mode where not only do you print using CMY, but the black pages you print using black only. So there you have a double optimization if you want. If you want to do this, you have to check whether the document is suitable for that. Why could it not be suitable? Well, think about this. You're taking a document that was intended to be printed on CMYK and you're printing it using CMY. Yeah? What's the first thing they will tell you when you're using text in a CMYK document? They will probably tell you that you need to, if it's dark, close to black, you need to print it using pure black. Yeah? Well, if you're taking small text that is pure black and you're printing it in an EPM workflow, you're going to be printing that small text using CMY, and that could cause problems, registration problems, for example. Yeah? So if you're printing a document in this kind of workflow, you want to detect things like that. Is there small black text in this document? And you can already see at the bottom here of my screen right now, there is a check, a pre-flight check that sees does the document contain small black text? But notice that it says on color pages. Of course, if a page is completely black, it doesn't matter. Yeah? I need to have that information, and that is what this first bit here does. If I have a document that comes in, I want to figure out which pages are black only and which pages contain color. The pages that contain color, I'm going to have to analyze and see how much color is there. And if I convert that page into a CMY page, am I going to lose any of the color? In other words, what is the delta E between a page that contains color before and after conversion? Because if there is too much color difference, I probably don't want to print that document using EPM because the result is visually not going to be the same. Yeah? On the other hand, if I'm using EPM plus K and I'm going to print a bunch of pages as black, I want to convert all the pages that contain only black content to real black, meaning device gray. Because that way I am certain that this RIP from this device that I'm going to print it on is going to recognize that this page is black and is actually going to print it that way. Yeah? So for both of these reasons, I need to know where are the color pages and where are the black pages. And that is what this check does. It does a pre-flight check on, let me see if I can open this. It does a pre-flight check that is based on rendering the document, and it's going to see what I have in this document, whether there is anything that will mark on cyan, magenta, yellow, or any of the spot plates. In most of these workflows, you probably don't want spot color to begin with, and you could take care of that ahead of time in this process plan. But in this version of the process plan, I just say, if there is anything that is not black, then I want to know about it. And the threshold at this point is 0, so it says as soon as there is color, I want to know about it. You could, and this is something that is done, you could increase this threshold here so that you also, for example, allow color pages that have just a little bit of color. And then they might get printed as black afterwards, but maybe that's not too bad if it's only a pixel or two where that would happen. So that is a pre-flight check that is run, and that pre-flight check will give me as a result, and that is what then happens afterwards. So that pre-flight check will give me as a result a list of all the pages that are not empty and only contain black. Yeah. And then I have a little script. When I say a little script and I open it, I can always hear people say this is not a little script, but here I have a little script, and that does the analysis of what comes before. I don't want to go through all of this, yeah, but what it does is it looks at what kind of mode do we have. Is it EPM or is it EPM plus K? And then it will also search for, what are the pages that are neutral, so black only, and which pages have color. And it saves all of that information in variables, and that's what it does here, for example. It stores a lot of that stuff in variables so that it can be used later on in this process plan. One of the things that it will calculate, and let me see if I can find where that is here. One of the things that it calculates is the percentage of black-only pages in the document. Why? Well, it goes back to the same principle that we're trying to apply. If I'm using EPM plus K mode, so EPM plus black, and I'm going to print a document where every page that contains colors is used on CMY and the other pages are painted in black, then I have no problem. Yeah, black pages are always going to be printed black and it's always going to be saving. If I print using EPM, what I said is every page is printed using CMY. That implies that a page that was black to begin with, only black, is now also printed as CMY. So instead of using one separation to print that page, all of a sudden I'm using 3 separations. If my whole document is black, it means that the document now became 3 times as expensive and it will take 3 times as long. That's not what we want. So if we're going to print a document in EPM, it can't have too many black pages because that would go against the saving that we want to accomplish. Yeah? So we calculate what the percentage of black pages is. And if that is too high, then we're going to do something about that. The process plan then says, is it EPM or EPM plus K? If it's EPM plus K, it goes in one direction, the green one here. If it's EPM, it goes in the other direction. And then there are a number of checks to determine what's happening. Is there actually a problem in this document or not? And again, I'm not going to go in all the details. Let me just get through this a little bit further, and then I'll gladly answer questions. But so, for example, in an EPM mode, it is going to check that percentage of black-only pages. And if there are too many, it is going to filter it out and generate a pre-flight error. Yeah? On the other side, you see that I don't do that. And then there is a conversion to CMY. So we convert the whole document from CMYK to CMY. I'm going to focus on one part here. So I do that conversion and then I do a comparison. So the document that comes in is CMYK, I convert the whole thing to CMY, and then I do a comparison between before and after. If there are differences with the setting that I have, I say, no, this document is not suitable. It can't be printed in that way. You have to print it using regular CMYK. If the document is equal after that, within our delta E limit that we've set, then it's going to send it to the next stage. And the next stage, and I think actually this should be the, looks like it, no. So we're sending it to the next stage, and in the next stage I'm saying, yes, but what I want to send to the RIP is not this document that was converted to CMY, but I want to send the original document to the RIP, yeah, and let the RIP deal with it. Again, this might be different depending on the workflow that you're trying to build. But in this workflow, I'm doing the comparison. If the document is good, I'm picking up the original before conversion, and that goes to the exits, and then it can be printed as an EPM document. And if there was too much difference, it's going to send it to the other exit, and then it doesn't get printed using EPM. As said in the beginning, this is not something that is complete, but it is something that this new technology within pdfToolbox to compare based on color inside of a process plan allows you to do much easier than it otherwise would. And if you're watching this and you're interested in this kind of workflow, I would urge you to get in contact and let us know. And then let's see what this does for you and whether we can get it in a state where you can actually use this in production. Questions?
So question number 1 is, most of the DFEs do this automatically, or do you have any other inputs?
No. Some DFEs, I would not say most, some DFEs have some capabilities in this. In most cases, you still need to validate that a file is going to be suitable or not. And I know a whole bunch of DFEs who don't do that. Yeah? Where before you send files to the DFE, you need to decide whether you're going to just print it normally or you're going to go for some kind of higher efficiency mode like EPM or EPM plus K. So if you have a DFE that does this, great, then you don't need this. Yeah? But in an environment where the DFE doesn't handle this, then you need to do a check ahead of time. And I think in pdfToolbox 12, even though this might not be ideal yet, but I think we have the technology on board to now implement that kind of check and also do a number of the preparation steps that you need to do in order to clean up the file and then send it to the DFE. Yeah? And that's the kind of environment that this was invented to. So again, if your DFE does this, good for you, then you don't need this.
Another question is, which DFE can do this fully automatically?
Depends on what you mean by fully automatically. EPM, for example, if you look at the HP implementations, I don't know whether it's for all of them, but some of them certainly do this kind of processing or can do this kind of processing. But there again, in that case, you still need to figure out which files are suitable to use this or not.
This question also goes to the audience. If someone knows, they can post it to the chat window. And now the third question is, how does it compare to HP's technology?
HP's technology is what they have in the DFE itself. Yeah. So again, this is intended to have and to be in front of the DFE and see whether a file is suitable for this or not. I know there is an implementation that exists for in Switch, something that HP has created in Switch. This is, I don't think, as advanced as that at the moment. And that is one of the things that would remain to be seen, is whether with the approach we're taking here and the delta E comparisons we have in pdfToolbox, whether we can come to a situation where this is usable in actual production or what things might still be missing. When we're saying it's a work in progress, what we're saying is we implemented this color comparison technology in here. We believe that is a first step. The question is, what other steps do we need to take in order to make this more usable in this kind of environment.
So continuing what you just said, do we have any percentage figure of files that pass or fail this check?
No.
Okay.
Too early for that. I would be very interested in doing some of that research, but at the moment I have no idea. And I think also, and this is always the case with these kinds of scenarios, I think it will be very different depending on what kind of environment you are in. Someone who gets files from schools and prints those is going to have other experiences than someone who runs a generic print shop, for example, where you get all kinds of things that then get digitally printed. So I'm pretty sure it's going to depend highly and difference highly in different environments.